Let's solve the next question, which is question number 10. And this question says a defect which could have been removed during the initial stage is removed in a later stage. How does this affect the cost? So we could remove this defect at the initial stage, for example in requirements or design, but we removed it in a later stage, for example in unit testing or system testing, or even after deploying the software to the customer. How does this affect the cost? We said in a previous question that the cost of defects depends on the impact of the defects found. The earlier the defect is found, the easier and less costly it is to fix these defects. So like we see in this graph, if we find a defect in requirements, this is not a big problem. If we find it in design, this is not a problem. If we find it in coding, it will not cost a lot, but if we find it in testing, it will cost a relative cost. But if we find it in operation, okay, this means that the customer or the client found the defect after we delivered it to him. In this case, this is a very big problem. That's why if we find defects in specifications or analysis, this means that this defect is relatively cheaper to fix. And like he says here, if these defects somehow get missed by testers, and if they are identified during the user acceptance phase, then it can be way too expensive to fix such type of errors. So the earlier we find a defect, the cheaper it becomes to fix this defect. And one of the 7 principles of testing states that early testing saves time and money. The next question says, what is change-related testing and why do we use it? Okay, or what is the difference between confirmation testing and regression testing? It can come in 2 ways. So if he asks you about change-related testing, we can say that change-related testing is a type of testing. It is a type of testing that is performed after a change is happened to the software. And the change that happens to the software will require 2 types of testing: confirmation testing or retesting, and regression testing. The first is confirmation testing or retesting. So when you find a defect, like we explained in the defect lifecycle, after the developer fixes this defect, you perform confirmation testing or retesting in order to make sure that this defect is fixed correctly. So like we see here, when a test fails because of the defect, then the defect is reported and a new version of the software is expected that has the defect fixed. In this case, we need to execute the test again to confirm that whether the defect got actually fixed or not. This is confirmation testing or retesting. On the other hand, we have regression testing. And regression testing means that we test the parts of the software that were not changed, okay? We changed something in a functionality, but this functionality affects other functionalities. That's why we will test those other functionalities in order to make sure that they are still working like they were working in a good way in the previous build or the previous version. So regression testing is type of software testing to confirm that a recent program or code change has not adversely affected existing features. Of course, we use impact analysis to know how much regression testing will be required. So for example, the customer wants to make some adjustments to the software. Those adjustments were not part of the contract that was written at the beginning of the project. In this case, we tell this customer, okay, this change will require this amount of regression testing. Why? Because we performed the impact analysis, and this impact analysis told us that we will require this amount of change, and of course this will require this amount of money. So do you need this change or not? Does the change deserve the amount of time and money that will be invested in it or not? Okay, this is the first step in performing impact analysis. And after we perform the change, after we execute it, we perform impact analysis again for us, okay? In this case, we perform it in order to know how much regression testing will be required and what are the parts of the system that we will perform regression testing on. Of course, it is a very good thing to automate your regression tests, but we are still in the manual tester interview questions, so we will not talk about this point now. The next question says, what is the difference between black box, white box and gray box testing? So when we are testing our software, we might be testing it using black box testing or white box testing. And let me tell you something important here. He is not asking about black box techniques and white box techniques. He is asking you about the definition of black box testing and white box testing. So some people, when they go to an interview and I ask them, for example, what is the difference between black box testing and white box testing? He begins to tell me, okay, black box testing means that we have equivalence partitioning, boundary value analysis, and white box testing means that we have statement and decision coverage. Okay, this means that he is not focusing on the questions that I'm asking, and this is a very bad trait in the tester. Okay, the tester must be a person who focuses very well on what he is told. So when we ask about what is black box testing and what is white box testing, I'm asking about the definition of each one of them. So black box testing is a software testing method in which the internal structure or design or implementation of the item being tested is not known to the tester. So for example, this is my mobile phone. If I'm testing this mobile phone using black box testing, I will provide input to the mobile phone and I will wait for output. Okay, I don't know anything about the internal structure of it. I'm using it as a user, as an experienced user. On the other hand, if I'm testing the mobile phone using white box testing, in this case I will provide input too, but I will see the internal structure. Okay, I will open the mobile and see what is happening to the input that I am providing. So here, white box testing is a software testing method in which the internal structure, design, implementation of the item being tested is known to the tester. Another mistake that many people do in interviews is that when I ask you, for example, if I am reviewing the code, is this white box testing or black box testing? Okay, reviewing the code is static testing. Black box testing and white box testing are dynamic testing. So here we are talking about executing the software. We are providing input and waiting for output. So white box testing is dynamic testing. Okay, we open the software, but we provide input and see what happens to this input. But reviewing the code is a static activity. In this static activity, which is reviewing the code, we don't provide input to the code. We just read it and review it. We also have gray box testing. And gray box testing is a software testing technique to test the software with partial knowledge of the internal structure of the application. So for example, if I'm opening a page in our website and this page doesn't open correctly, okay, so here I am performing black box testing, but I need to know the reason. Why doesn't this page open? So in this case, I might use gray box testing. I might, for example, take the URL of the website, open it using Postman and see the response. Okay, what is the response code? What is the body of the response? In this case, for example, I might find the response code 401 and now I understand why doesn't this page open. So here I am performing black box testing, but I also used a white box technique, which is API testing. In this case, we can call this type of testing gray box testing.